Here is the last section of this chapter 8.5. So this is other trig functions. So sine, cosine are not the only trig functions that exist. There's other functions that, are very unique to trigonometry. There's tangent. Okay, so tangent here, a way that we can talk about tangent is that it's sine over cosine, which is just equal to the y over the x. And remember that the y was basically the sine function, the x was the cosine function, so it's just a division between them. Cotangent is basically the cosine over the sine, which is going to be the x over the y. So you can think about the cotangent as the reciprocal of tangent. Secant here is 1 over cosine, which is r over x, so it's the reciprocal of cosine. And cosecant, which we write at c as c, theta is equal to 1 over sine, which is r over y, which is a reciprocal of sine. So these can be really confusing because the reciprocals are actually opposites. You would think that secant goes with sine, but they don't. They're actually opposites. So you see secant goes with cosine and cosecant goes with sine. Okay, and tangent and cotangent are obviously the opposites of each other. Okay, so these are just basically how you would find all of the rest of the trig functions. So we're just going to do a couple problems. We're not going to be graphing them. Graphing them are a little bit of a stretch for this class, but just note that there are graphs for tangent, cotangent, secant, and cosecant. Okay, but we just won't talk about them in this class. So, so let's just do some examples. So let's find tangent of theta, cotangent of theta, secant of theta, and cosecant of theta. Okay. So for the following, so let's say we had x and y, and we want to find this angle theta, and here this point is going to be -5, 12. Okay, this is theta. Okay, so we want to figure out what exactly these guys will be. Okay, so the first thing to figure out, if you remember, is that if you look at these formulas, we basically have our x and we also have our y. All we just need to figure out is what is going to be our r value. So remember, r is going to be equal to the square root of x squared plus y squared. Okay, so x squared in this case is going to be equal to a -5 squared. Y squared is going to be equal to 12 squared. Okay, this is going to give me the square root of 25 plus 144, which is going to give me the square root of 169, which gives me 13. Okay, so that's what r equals to. So now all we have to do is just plug them all in. So let's first start out, let me do a different color. So let's say we wanted to do tangent of theta. So tangent of theta is equal to y over x. The y in this case is 12. The x is equal to -5, so that's what tangent is. Notice that I could have also found the sine and the cosine, divided them, and I still would have gotten the same exact thing. Okay, all right, now we're looking for the cotangent of theta. The cotangent of theta is the x over the y, which is going to be the -5 over 12. So notice here that these two are the opposites of each other. Okay, now let's find the secant of theta. So the secant of theta is going to be equal to 1 over cosine, or r over x. In this case, our r is going to be 13, and our x is going to be equal to -5. Okay, and then cosecant of theta is going to be equal to r over y. That's going to be equal to 13 over 12. Okay, all right, so nothing really to these problems, just we have another set of formulas that we need to be able to figure out. Now, obviously, we can also figure out what the tangent of pi over 6 is. So if we want to figure out the tangent of pi over 6, we can also figure that thing out. And then the way that we figure it out is that, well, if you remember the unit circle, and I'm not going to draw all of it, but if you remember the unit circle at pi over 6, which is around here, 30 degrees, this point is square root of 3 over 2, 1/2. Remember, this is our x and this is our y value. Okay, so the way that you would want to find the tangent of pi over 6, well, the way that you would do it is, well, you know that this is going to be y over x, and you're going to have 1/2 divided by square root of 3 over 2. Okay, so you would divide this, okay, and what you would end up getting would be 1 over square root of 3. Okay, we want to rationalize this, so you're going to have square root of 3 over 3. Okay, same thing with the sine, oh, not the sine. Let's say we wanted to figure out the secant. So if we want to find the secant of pi over 6, Okay, well, if we look at the formulas for secant, this one is not going to quite work. You actually can, because r in this case would be equal to 1. So you can use either one that you want. So in this case, you can do 1 over cosine of theta, which in this case is 1 over pi over 6. So you'll have 1 over, what is the cosine of pi over 6? Well, the cosine is our x value, which is square root of 3 over 2, which is equal to 2 over square root of 3. And then rationalize this out, and you get 2 square root of 3 divided by 3. Okay. Now, let's say you wanted to figure out, let's say you wanted to find out what the tangent of pi over 2 was. Okay, so the tangent of pi over 2, well, let's look at pi over 2. Here is pi over 2, and at pi over 2 is 90 degrees, which is equal to 0, 1. That's a point associated with that. We want to find the y over the x. Y in this case is going to be equal to 1, x is going to be equal to 0. Oh, well, you can't have 0 on the bottom, so this thing is going to be undefined. So notice that because tangent has a division by, tangent's going to sometimes have a division by 0, and so is the cosecant and the cosecant and the cotangent. So all of these problems, you're always going to have, maybe you might have some values that are undefined. Do not leave it as 1 over 0. You have to write undefined, okay, because these values do not exist in this in their domain. So so this is how you might want to be able to do it. Look at the unit circle, be able to divide them back and forth, and that's just basically the gist of most of these other trigonometric functions. So in the next video, we're going to do a little bit of more calculus with these functions, and then that will conclude chapter 8.